Hey, we're back. We're talking about pseudocode in this one, specifically list. A reminder that pseudocode is what the actual AP exam will be written in. The course itself is designed to be program language agnostic, which means the teacher can basically teach it in whatever language that they want, as long as, the principles are taught. And realities are all the languages that get used, Java, C++, Python, it doesn't matter. They fundamentally use the same concepts. If statements, that is conditionals, loops, methods, or procedures, functions, whatever you want to call them. So lists are going to be pseudocode's variant or version of arrays. Okay. So the AP Computer Science Principles course is designed to be programming language agnostic. As such, all programming questions appearing on the AP CSP exam will be written in pseudocode developed by the College Board. While there are a fair number of similarities between pseudocode list and Java arrays, this is where the two languages deviate the most. The pseudocode list, as we're going to see, actually mirror Python more than they do Java arrays, but there are analogs, right? There are direct analogs between the two that we can get it. I promise you. For starters, a list can only be constructed from an initializer list. This Java syntax where we could create an array with a length of 4 and it just be an empty array, well, it would assume default values, right? It would be filled with 4 zeros because this is an int array. There's basically only an initializer list. If we look over here on the left-hand side at the pseudocode variant, you'll notice there is no data type. That's because pseudocode is effectively dynamically typed, meaning there aren't data types. Simply put, you can store whatever you want to in a variable. Now, there are languages that exist like this. Python, JavaScript are like this. But Java, if you'll remember, is statically typed, meaning the variable has to have a data type. And once you declare it, only that data type can be stored in that variable. Some would say this is good. Some would say this is bad. Most beginners like dynamically typed because they could just put whatever they want to in a variable and they don't have to worry about data types. But if you learn, which we did, a statically typed language first, you tend to like it better because like later on, as we're going to see when we look at a procedure header, which is effectively a method header, you know what data type is coming in. The fact that it's limited actually makes it easier to kind of rationalize what's going on. So this statement will construct a list with a length of 4 and assign the values 1, 3, 3, and 7 to the corresponding indices. So this is a direct analog to our initializer list. Right? Visually, it looks something like this. However, list indices begin at index 1, not 0. Now, this one bugs me. This one bugs me a lot. Because for the most part, it is mirroring Python, right? Lists are going to be very similar to how arrays/list are handled in the Python programming languages. However, even in that language, the indices begin at 0. The only language I can think of that starts at index 1 off the top of my head is Lua, Lua. I know there are more, but all of the popular ones that you have heard of, Java, C++, Python, JavaScript, C#, they all start at 0. So it bugs me that the College Board does this. But you have to keep track of it. Each element in a list can be referenced via an integer index and square bracket notation. We saw this similar concept with our Java arrays. On the left-hand side, I'm creating a list using an initializer list, the only way you can create a list. And then I can take index 2 and store in a 0. Reminder that this little arrow shows is equivalent to our equals relational operator. We're saving in. No, I should say relational operator, or our assignment operator, right? We are saving in this list into this variable. We're saving in this 0 into this index. Now, display is going to be our analog for systemout.println, right? The left-hand side is equivalent to the right-hand side. You'll notice that the indices are 1 off here. That's because the pseudocode list actually starts at index 1, which means I would be changing this 3, the second element, to a 0. Over here, same thing. I would be changing the second element to a 0 because our index starts at 0. Okay. Since list indices begin at index 1, referencing an element at index 0 will generate an error. In theory, there is no actual compiler for pseudocode, but you should recognize that index 0 doesn't exist, and that would be out of bounds. However, note that the last index is the length. All right, this has a length of 4, which means length is in bounds. This means you can reference via going mylist length mylist, and we'll talk about this length, right? I'm just using the square bracket notation. The name of my list is my list. I'm using square bracket notation in order to get a particular index. In this case, that index is going to be 4, which is the length of my list. That's right, the length procedure. Procedure, several words for this. In Java, we've been calling them methods. Function is another word for it, but they're interchangeable words, right? Procedure, function, method, they're all interchangeable. So length is a procedure, a method that returns the length of the specified list. That is the number of elements. Here I'm demonstrating on the left-hand side. My list has a length of 4, which I'm saving into len. Over here on the right-hand side, if we're talking about the Java analog, this is what it would look like. In fact, the College Board pseudocode defines several procedures that perform operations on the specified list. Here are the 4 list operations: procedures, methods, functions, commands. Command's not a good word. That will work with list. Okay. The first one we just saw, length. It evaluates, or that is returns, the number of elements in the list. By the way, we're going to talk about each of these, but a point is that on the actual exam, you will receive a document, right, which is in the course description, showing you list operations, right? So it's not like you got to remember these to a T. And realities are, with our experience with arrays, you can kind of figure out what's going on without having to go into much detail. So here they're showing how you can create a list. Here would be emptying out the list. Here I'm saving a list into another one. Accessing an index. We've talked about all these things so far. Saving an element into an index. Saving a single element into a different variable. So on and so forth. But then we get down to the 4 methods, the 4 procedures, right? There's length, remove, append, and insert. And as I said, you will receive this document on your test, meaning you'll have exactly this right there in front of you. So that's length. It'll tell you how many elements are in the list. There's also insert, which inserts value, that's this last parameter, into list. That's the first parameter here, at index I. Any elements in list at indices greater than or equal to I are shifted to the right. We don't have a direct analog for this in terms of arrays. There is something in Java called Arraylist, which will function similar to this, but when it comes to arrays themselves, we don't have a direct analog. As a result, the list length will increase by 1. Let's look at an example. Okay. Let's say that my list starts out as 1337. I'm going to insert into my list at index I 23. Now, I would be careful with these. Make sure you keep them straight. Again, it is on the document, right? I value. And it's a good thing that we have practiced using I to indicate an index, right? You could very easily see these two things getting, mixed up and it being a little bit confusing. But what's going to happen is that 23 is going to get inserted at index 2. That's right here, right? Our indices start at 1. So this is index 1, index 2. We'll put 23 right here, and we're not deleting 3. It's not going away. It's getting pushed. You can see the result here as a comment. That is what's happening to our list. 23 gets inserted at that spot, and the other elements are pushed, and as a result, our list is longer. That's what insert is doing. There is append, and the word append means specifically to add to the end, right? So we're just going to tack this one onto the end of the list, and as a result, the list is going to get larger by 1. Okay, so here we are tacking on to my list the number 404. Visually, it would look like this. Last one we got is remove. It removes the element at index I in list and shifts to the left any elements at indices greater than I. The length will decrease as a result. Okay, so here is our list 314, and I'm going to remove from my list 1. Be careful here. I have chosen this example on purpose. This number, this 1, it is the index, not the first occurrence, right? Not element 1, index 1. Okay, index 1 is actually a 3. So that is going to get deleted, but we're not leaving a 0. It is getting completely removed, and the list will dynamically adjust as a result, right? Those elements are going to shift over to close up that gap. As you can imagine, deleting something kind of in the middle would cause stuff to shift over as well. As you might expect, list traversal is frequent and important task that requires a loop. You can use some of the loops that we've talked about before when we previously talked about pseudocode. You can use a repeat loop to traverse a list. All right, our list is starting out here. We're going to create I and save in 1. That is our first index. We're going to save in length into len just to make it a little bit cleaner. And we're going to repeat len times. So this code is going to do 4 iterations where it displays my list at I and then do an I plus 1. Okay, so this would just print the contents of our list. You could use a repeat until loop, which I don't think gets used as much. You won't see this in pseudocode. Keep in mind, you're not writing pseudocode. You're just interpreting it, right? You're going to see multiple choice questions, and you got to figure out what's going on. Here we have our list. We have I starting at 1. We, again, pull in our length to a variable to clean it up, and we'll repeat until I is equal to len plus 1, until I is out of bounds, basically. Because remember, len, our length, is still in bounds. Index 4 is right here with this 7. So we will repeat until I is out of bounds, 1 more than our length. Again, just displaying the contents of array, increasing I by 1 each iteration. But the loop you will see used most often is going to be the for each loop. We are saving in our list. We are saying for each element, notice the E and not an I. That's very convenient, right? Because it is replacing that my list at I syntax. We're going to loop through my list, calling the current element E, and here I'm just displaying it. And you can see why we would tend to favor this, because it is so much cleaner. Okay, so while the other ones are possible, you are most likely, by a mile, going to encounter this one. Note that the pseudocode for each loop suffers from the same pros and cons as Java's for each loop. Right? We talked about the pros and cons of our for each loop when we looked at the Java for each loop, and it is the exact same. Pro, readability. That is definitely cleaner. We are never going to experience an index out of bounds because there is no index. There's no way to go beyond the array. You can only go from left to right, right, beginning to end. And we cannot modify the list elements, right? So changing E will change it for that iteration, but it won't change the actual array itself. If you want to change the array itself, the list itself, you got to reference the list. Note that the con, no index counter, is crossed out. The APCSP pseudocode does not define a direct analog for Java's for each loop, which ultimately means the index counter is declared and initialized outside the loop, no matter the loop. What do I mean? So one kind of con that I talked about when we got introduced to for loops is that in theory with a for loop, we couldn't access the index after the loop because it was contained in the header. Now, if you look at these loops, right, and with both the repeat until and the repeat loop, the index is declared before. Meaning with both of these examples, you can access the index after the loop. Okay, that's why I crossed off this con, because when it came to Java, it was kind of a con. I also talked about how it's kind of a positive thing because we get to reuse the index counter and we really like using I. But this, what was potentially a con with Java, and that we could not access the index after the loop was finished with a for loop, that is not the case with our pseudocode. So the AP CSP exam will frequently use an index counter in conjunction with a for each loop. I've seen this used quite a bit, where they actually create an index and have it increment along with it, which would allow you to not only access the element, but given an index, you could, in theory, use it to modify the array, right? So, or the list, I should say. So in this example, we have name list is in theory the list. I could do name list at index and be able to change it even though I'm using a for each loop because we have an index. So be on the lookout for that. This also means a for each loop can modify the elements in a list, but you'll need to reference the list element and square bracket notation. Hey, this is what I just talked about, right? Left-hand side over here, I have my index. We are using a for each loop to go through our name list, but here I am changing the list, right? I am referencing the list and referring to a specific index, and that will change it. This will modify the list because I'm referencing the list. However, over here on the right-hand side, notice I'm referring to name. Name is something that gets created and destroyed with each iteration, right? Behind the scenes, name gets created, we save in the current element, and then for the rest of the iteration, you can just refer to name, which is kind of a copy, but it's not the actual list itself. It's not the actual element itself. It's merely a copy. So whenever I say name, whenever I try to save Bob into name, that does change name, but just for that iteration, right? It stops existing. It gets recreated in the next iteration, and we never actually reference name list, which means the list is not getting modified over here on the right-hand side. Be on the lookout for that as well. Okay. That is the pseudocode list, and notice that we had the for each loop get introduced along with it. Yet again, you would receive a reference sheet. This is available online, by the way. This is just the course description at the end of it. Speaking of course description, they contain some sample problems, such as number 11, which we'll look at now. You see that it uses a list and it uses a for each loop. It says the following procedures are, of course, methods, functions, is intended to return the number of times the value val, that is the parameter that's coming in, appears in my list, the other parameter that's coming in. The procedure does not work as intended. Okay, so they number the lines so that they can reference them down in the actual answer choices, but we have a procedure being defined, a method being defined. Notice there's no return type because it doesn't matter. Pseudocode is dynamically typed, which means that we don't have to specify what type of data we're returning because we can return whatever we want. Okay, you can see that, oh, it's kind of nice to be able to return whatever you want, but there's also the downside of I'm looking at the header and I got no idea what data type this is spitting out. I have no idea what's ultimately getting returned. I'm not even looking down, but are we returning, a list? Are we going to return a single value? Okay. They told me that it's the number of times, so you can kind of figure out it's an integer, effectively, a whole number, but it's kind of nice. It's nice to see it up in the header. Anyway, the name of the procedure is count num occurrences. And again, we are taking in my list and val, and they don't have data types because it doesn't matter. There's really no such thing as data types. Okay, so we can kind of gather that this is a list and that this is a value in integer or double. Now we have our for each loop. We're going to loop through my list, calling the current element item. Count gets created and set to 0. Interesting. And then we have an if statement if the current element is equal to the one that I'm looking for. Single equal sign is fair use here. It is equivalent to our equals relational operator because this is the assignment operator. right? This arrow indicates assignment, which means we are free to use a single equal sign to check for equivalency. If the current item is the one that I'm looking for, I'm going to increase my count by 1, right? And we, in theory, do that for every element in our list. After the for each loop is over, we'll return count, which in theory is supposed to be the total number of occurrences. Which of the following changes can be made so the procedure will work as intended? I'm not even looking at the possible answers here because to me it's so obvious. Line 5 here is inside the loop, which means it is getting created and destroyed with each iteration. It is resetting back to 0 on each iteration, which means it has no value, right? Note that it has a value. It's just a value of 0. I guess in theory, if it's the last item, we would maybe have a value of 1. Something of note that if this was in Java, we would have a scope issue here anyway, right? This would be a syntax error if we were talking about Java, because this stops existing here, which means it doesn't even exist in this scope. So that would be a problem in terms of Java. As you will see in the pseudocode, scope is just not really an issue. We can access this. Okay, so with that in mind, what I want to do is take this thing out of the for each loop. I only want to declare it one time. I don't want it to get created and destroyed with each iteration, so we need to move it out, and that is what choice C is saying. Let's move the statement in line 5 so that it appears between lines 2 and 3. Okay. You can look through these sample problems. This is the only one in our sample problems that are dealing with list. So that is the one that I showed you. That is going to wrap up our procedures, our pseudocode dealing with list. I'll see you in the next one.